Section 1.1, from Chapter 1, Functions and Their Graphs. This section is lines in a plane. So just a little bit of review back from Algebra 1. The beginning of the notes give you a quick reminder on slope, the different special cases when we talk about a zero slope and an undefined slope, and then the form of the equation that we use typically is point slope form. I know previously in Algebra 1 and maybe a little bit in Algebra 2 students used slope intercept form, which is nice. However, that requires that you know the intercept, and a lot of times we don't. So I'm going to go ahead and just use point slope form for this. So I have an equation here, and I want to answer two questions based off of it. So I want to be parallel to this and perpendicular to this. So in order to do that, I need to calculate the slope out of this equation. So the first thing that I'm going to do is I'm going to take the equation that was given to me, and I'm going to put it into y equals mx plus b, just so I can extract the m from the equation. So let's take that here, move it down a little bit, and then solve for y. So again, to do that, I would minus the 5x to the other side, and I would add the 17, or just bring it down with me, and then divide by that -9. So I'm going to get a 5/9 slope, and honestly, I don't really care about the y-intercept because I'm not going to be using it. So the only thing that I'm going to focus on here is the very first part, which is going to be the slope of this thing. So this is really what I care about. Now, if I want to be parallel to this line, I need to use the exact same slope. So I'm going to use my 5/9, and then I'm going to use the point -410. So just taking out my point slope form. So I'll go ahead and write that down here. Y minus y1 is equal to m quantity x minus x1. And I'm just going to plug in the stuff that I know. Remember, the point that was given to you is the x1, y1. Don't replace the x and the y. Those are just the variables that you need to make sure that this is a linear equation. And then the 5/9 that we just found a second ago. So my y1 is going to be 10, so it's going to be minus 10. I want to be parallel, so I'm going to use the exact same slope that I calculated just a second ago. And since this is a -4 that I'm going to go through in the equation is minus, this is going to be plus. So there's the answer to the first question. If you want to go through and distribute the 5/9, you can, but I don't see the point in doing that. It's more work, which if that's what you're up for, then go right ahead. So I'm going to do the exact same thing over here. However, I've already done the work, so I'm just going to copy my slope down from the equation, which is going to be the 5/9. Now, I need a perpendicular slope. To get the perpendicular slope, I am going to find the reciprocal of this, so I'm going to flip it over, and then I'm going to change the sign. It was positive, it now becomes negative. One way that you can check and make sure that your slopes, most of your slopes are perpendiculars, you multiply them together and you should get -1. The only time you won't is the special cases. So now I'm going to go through and I'm going to use my new slope here. This is the one I want to use for perpendicular. So I do the exact same thing I just did a second ago, except now I'm going to use the -9/5 and the new point here. So again, using the y minus y1 is equal to m quantity x minus x1, so my point slope form. I'm just going to go ahead and plug my stuff in. So I get y, my y1 was 15, my slope, which is now -9/5 because I want perpendicular, and x minus, and my x value is 7. Question number 3 is just a reminder on finding x and y intercepts. I chose a linear equations because the section of 1.1 is about lines, but remember, regardless of what the equation looks like or what shape it would give you if you were to graph it, the only thing that you need to do for x or y intercepts is just to plug in 0. So, and it doesn't really matter what the equation looks like. It could have parentheses, it could look like a mess. It doesn't really matter, you just cram zeros in. So to find the x-intercept, I'm going to plug in y equals 0. So I'm just going to write my equation until I run into the y, and then I'm going to rip it out and put a 0 in its place. Notice that I didn't do any manipulation of the equation in the first place because it's not necessary. Some things will end up falling out anyway because of the 0, which is nice, which is exactly what happens here. So this negative 23 times 0 is going to disappear, and now all I have is 11x plus 18 is equal to 0, which is really not bad. I'm going to minus the 18, and then I'm going to divide by 11. The only thing that you need to be aware of here after plugging in zeros is to not stop. X equals negative 11/18 isn't the answer. An intercept is an actual location on a graph, so you will be required, and hopefully have been in the past, to write this as a point. So remember, you plugged in 0 for y, so we have a 0 in the y value of the point, and then the x that you came up with. Let's go ahead and do the exact same thing, but let's do it for the x this time. So I'm going to plug in 0 for my x this time, because I'm trying to find my y-intercept. So same work. You just have to start from the beginning again, though. You don't want to mix the two zeros at the same time, so you'll get something that doesn't make any sense. So if I plug in my 0 for my x this time, I get negative 23y plus 18 is equal to 0. I get the exact same thing to happen with the x that just happened with the y a little bit ago. It's basically just going to disappear. Write down what I have, negative 23y plus 18 is equal to 0, and then solve that equation accordingly. So minus the 18, and then divide by negative 23. Now, if you get fractions that can be simplified, then you are required to do so. However, 23 is prime, and nothing's going to go into that other than 1 and 23, and dividing by 1 doesn't do me any good. So I'm going to plug in, remember I plugged in 0 for my x. Now for my y, I end up with 18 over 23. So just a little bit of review of some things that we do with linear equations. So on the first slide we had two questions where we wanted to find perpendicular and parallel, so basically just use the slope. And then from here we're just x and y intercepts, so just plug some numbers in.